What do you mean by bitumen emulsion? To get a fluid consistency, dispersing bitumen globules in an aqueous solution, that is water with dispersing agent. 60% of the water and the remaining 40% will be bitumen, and this one is known as an cold bitumen mix, and properties depends on the grade, water quantity or emulsion, and the current bitumen emulsions are RS, MS, SS. Modified bitumen binders. To improve the properties of the bitumen, additives are mixed. Polymer modified bitumen is used only in the wearing course depending on the severity of climatic and weather conditions. The most important advantages of modified bitumen. What are the advantages? Actually, as the name indicates, modified bitumen, which is having the more advantages than the normal types of bitumen. The advantages of the modified bitumen will be lower susceptibility to daily seasonal temperature variations, because we have can see that in the rainy season there may be a full sunlight, or in the summer season automatically they may be subjected to the heavy rains. In such cases the bitumen may be effects. So usage of this modified bitumen which can be withstand against the temperature variations. Higher resistance to deformation at the high pavement temperature. If it is subjected to heavy temperature, it may be high resistance to deformation. Next, better age resistance properties. Higher fatigue. What do you mean by fatigue? We are considering a road. Assume this is our vehicle, this one is our road. These are the wheels of the vehicles. When the continuous movement of wheels over the particular point, with respect to the particular time, that type of the load is known as fatigue load, or series of circular loads. These type of the load are called as an fatigue load. 90% on the road surface the loads are expected to be fatigue loads only. Next, better adhesion between the aggregates and the binder. Next, prevention of cracking and reflective cracking. Next one, functions of binder. What do you mean by functions of binder? As the name indicates, binder which binds together, used on the surface course, used on the base course depending on the traffic, used in the preparation of mixes, because the bonding should be more, used as a primer coat over a granular base course, because which gives the adhesion between the primer coat as well as a granular base course, and also used in a soil stabilization. And the most important thing is which may be sealer material or filling joints and cracks on a CC pavements. What do you mean by CC pavement? Cement concrete pavements. There will be some cracks like this. So CC road will be subjected to like this. Here there will be a cracks or some small type of caps because of temperature variations, that is known as in such type of the cracks or variations that should be can be filled by with the material. Requirements. What are the requirements? Adequate viscosity. This one should be the most important requirement for the bitumen. And the next, heating bitumen, aggregates, cutback, emulsions. Sufficient viscosity on cooling, compact surface with no deformation. Next one is form a thin film around aggregates. Over the aggregates, it should be a form a small thin film over the aggregates. Next, sufficient ductility. When we are considering about the ductility, if the bitumen is like this round shape or any shape, when we are subjected to tensile force, that should be having a ductile in nature. And we are conducting a one test on this ductility test on bitumen. And the next we can see, next, Tests on bitumen. What are the tests? First one is a penetration test, ductility test, softening point, specific gravity test, viscosity test, flash and fire test, float test, water content test, loss on heating test. In the lab, in the previous semester in the laboratory, we have already learned penetration test, ductility test, softening point test, specific gravity, viscosity, flash and fire. So just once again you can go through the experiments, the results as well as the procedure. Briefly I will go here one by one. First one, penetration test. What is the importance of penetration test, which measures the softness of the bitumen? Suppose example, if the bitumen is very soft, the penetration value will be more. If the bitumen is very hard, the penetration value will be automatically less, which measures the hardness or softness of the bitumen, which measures the penetration depth in a tenth of a millimeter to withstand with a standard loaded needle will penetrates in 5 seconds. So wait for a minute. Here see, this one is the bitumen. Over here we are subjected to a plunger, nothing but a penetration. In a 5 seconds, what will be the depth of the penetration? This is known as a depth of the penetration. See here, clearly given. That should be almost less when we are comparing to the other materials. And the standardized equipments is should be a BIS, Bureau of Indian Standards. Next, penetrometer device, which consists having a needle of 100 grams device for a releasing and locking positions. This one is the experiment setup which is used in our laboratory. Here we will fill the bitumen here. With respect to the loading, pressing this knob, automatically the penetration will be impacted on a bitumen. What will be the bitumen penetration for 5 seconds? That should be recorded. Procedure. Bitumen is heated to pouring a consistency. Because of the normal temperature, bitumen will be in a semi-solid state. So to get a fluidity should be given a heated for a pouring consistency. Placed in a container to depth of about minimum 15 mm excess of expected penetration, and it is conducted at a temperature of 25 degrees Celsius, highly fluctuated with a small inaccuracy. Next, results are used for the grading of bitumen, because these are the gradings: 40 by 50, 80 by 90, these are the bitumen grades. And the next test is ductility test. Second test, ductility. As I already told in the previous slide, the ductility can be defined as the property which permits the bitumen to undergo greater deformation without breaking. Greater deformation without breaking. When we are subjected to tensile forces, the bitumen should be elongated but should not be break. We should be having a greatest deformation, but we should not be having a breaking. If you want extra information or videos, refer video lecturing. I have already uploaded in YouTube for the videos. Next, ductility is defined as the distance in centimeter in which the standard sample or briquette of the material will be elongated without breaking. The bitumen sample is heated. Just I am going through the briefly because we have already learned these all experiments in the previous semester laboratory. The bitumen sample is heated and poured in the mold assembly, placed on a plate and cooled at a temperature of 27 degrees Celsius, that is called as a water bath, and sides are removed. So you can see here, this one is actually called as an ductility mold. Here the bitumen should be heated, and for the all inner surface of the this ductility mold we should apply the material that should be non-viscous material. Because of the property of the bitumen that will be sticky on this surface, to avoid that we should apply the interior material that should be non-viscous. After that we should fill the bitumen ductility mold with the bitumen and should be keep it for a water bath around 28 degrees Celsius, 27 to 28 degrees Celsius for 40 to 45 minutes for the cooling. Then here can call it as a point A and B should be apply the tensile force. Automatically the bitumen will be subjected to tensile in nature. Whereas as the load increases, the deformation is also goes on increasing up to certain limit. After the point of the breaking point, the bitumen will be subjected, gets breaked. And measure the distance, at what distance the bitumen goes in a deformation without breaking. That is known as a ductility property of material. So here we can say this one is the starting point. This one is the, as the ductility goes on increasing, the bitumen may be subjected to a deformation. At the last point, they here the point may be broken. That point is known as a ductility point of bitumen. And the next one is third one, softening point test. Actually this can be done by ring and ball, and the temperature at which the bitumen attains particular degree of softening. Because as already told, bitumen usually in the normal temperature will be in a semi solid state. When we are subjected to a temperature, automatically the bitumen will be subjected to softening, nothing but a smoothness, and it may be subjected to viscosity or fluidity test. In this test, at what temperature the bitumen will be converted to softening? Because of this test, we are using a one beaker, and that be completely filled up with the water. And this instrumental setup, here we can see these are the rings are placed in this place. Over that, two spherical balls are placed. When the then the beaker is completely filled up with the water, and we are increasing the temperature. Because of the uniformity to give the temperature over the beaker, we are providing the water as an condenser. The water may be increase water the temperature of the water goes on increases, the softening point of the bitumen goes on decreases. At what point the bitumen breaks the softening point and the balls gets collected in the bottom of the beaker, that particular point is known as a softening point of the bitumen. The whole experiment should be depend on temperature of the water. That's why we are using the thermometer. You can see here a brass ring containing test sample suspended in a liquid or glycerin, heating at a 5 degrees Celsius per minute. Softening point denotes the temperature at which the bitumen touches the base of the metal plate. So you can see the setup here. Here the ring and balls both are placed inside of the water, and that is submerged in a water. But the temperature of the water goes on increases. As the temperature goes on increases, the softening point of the bitumen goes on decreases. At particular point, the balls are tends to move in a downward direction, and which reaches the bottom of the plate. That particular temperature is noted down. Here we can see here clearly. So here both are same setup only. Just for the identification purpose, we have shown a different pictures. Here the balls are at a upper side. Here the balls are reaches already bottom of the beaker. The beaker is completely filled up with the water, and the thermometer is fixed. As the temperature goes on increases, here we can see here starting point and the end point. As the temperature goes on increases, the balls are tends to move reaches in a downward direction. We can see here this one is known as an end point. Next, specific gravity test. We have already know specific gravity of the cement, specific gravity of the coarse aggregate, specific gravity of the fine aggregate. What do you mean by specific gravity? So specific gravity can be defined as weight or mass of the material to the equal volume of the water. Usually specific gravity of water will be 1. Specific gravity of mercury will be 13.6. Nothing but when we are considering mass of the material divided by equal volume of water. So when we are considering the mass of the material is nothing but here bitumen. That should be equal to the volume of the water. So for this purpose, we are classification as an Density influenced by chemical composition, and using a pyknometer method or any standard method we can get the specific gravity test. Usually the specific gravity of the bitumen will be 0.97 to 1.02. For specific gravity of water is 1, specific gravity of the bitumen is varies from 0.97 to 1.02. Next one is viscosity test. What do you mean by viscosity test? As already told, bitumen will be having a viscous properties. It is a fluid property of the bitumen. When the temperature goes on increases, the bitumen can be subjected to viscosity, which measures the resistance to flow. Resistance to flow is nothing but viscosity. When the viscosity goes on increasing, there will be a change in, there should be a change in temperature. That's why we are conducting the viscosity. For very low and high viscosity decreases the stability of mix. Assume we have already placed a bitumen over a tar. When the road is subjected to heavy heat in a in summer season, that all may subjected to effects on viscosity. In such cases, if you wanted to walk over the road, that will be sticky part to that will be attached to the your pavements. That's why we are using the viscosity test. High viscosity non-homogeneous means low viscosity no uniform film on aggregates. Next, orifice type of viscometer and other types of the equipment is used. If you wanted to see a viscosity test, refer to the our laboratory, and we have already done experiments in the previous semester only. Next, flash and fire test. As the name indicates, flash and fire, for what reason, for what temperature the bitumen will be subjected to fire, that is known as an flash and fire test. For especially this test is subjected for higher temperature, and these are the inflammable. Important to know where it is catches the fire. According to the BIS, flash point is the temperature at which the vapor of the bitumen momentarily catches the fire in the form of flash. That's why we can call it as a flash and fire. Fire point is the temperature at which the material gets ignited and burns. As I already told, because the temperature of the bitumen maximum is around 130 to 175. At the 175 degrees Celsius, the bitumen may be subjected to flash fire that maybe catches the fire and it goes for self-burning. That point is known as a flash and fire test. The next one is water content test. Bitumen distilled in a petroleum and it should be heated. For weight for the water condensed and cooled is expressed as the percentage of the by of original sample. This is nothing but a normal method what we have conducted as in a basic material testing laboratory, geotechnical laboratory, and highway and concrete laboratory. The what is the aim of this test? What quantity of the water is presented in the bitumen, and for what particular quantity the water may be subject, the material may be subjected to completely dry. This type of the method is known as a water content test. And the last one is loss on heating test. When the uh, bitumen is subjected to heating, there will be a loss. How much quantity of the loss and how we will measure the loss, that should be done by loss on heating test. Bitumen loses its volatility upon heating and gets hardened. When you are subjected to continuous heating, the automatically the bitumen will loses its volatility. Because the reason we need to conduct this experiment, and take 50 grams of a sample and weighed and heated for 163 degrees Celsius for 5 hours, and the sample is weighed after heating, automatically there should be a loss in weight, that is known as a loss on heating. A loss on heat which should be expressed in terms of percentage, nothing but for a paving mixes not more than 1% is allowed. If it is allowed more than 1%, you can see, however the bitumen has a penetration value 150 to 200 mm, 2% is allowed. Thank you. If you have any doubts and inquiries, just drop a message or send an email.